We all love a good mystery, and this one has kept scientists scratching their heads for decades. It's me, and you're watching this channel. And today we're answering the question, where is Saturn's missing helium? If you like optimistic science and text stories, stay tuned for more. Back in 1980, the Voyager probes took humanity's first close look at the mysterious ringed planet Saturn. These incredible spacecraft had traveled over 2 billion kilometers from Earth to reach the gas giant, snapping thousands of incredible photos along the way. But even though the mission was over 40 years ago, data from the Voyager probes continues to surprise scientists today. Take, for example, the swings in Saturn's atmosphere. You see, long before Voyager arrived, scientists expected that just like our Sun, Saturn would emit light as a result of nuclear fusion happening deep in its core. So they assumed that Saturn's atmosphere would have a nice even glow all the way around the planet. But when Voyager reached Saturn, scientists found that the atmosphere was emitting 20% less light than expected. This meant that something was preventing the atmosphere from being as luminous as it should be, and it didn't make sense. You see, this effect known as hydrostatic equilibrium happens when pressure from the inside of a planet balances the gravitational force pulling inward from the outside. If there's too much or too little gravity, then the planet will collapse in on itself until the forces balance out. So what could cause Saturn's atmosphere to suddenly collapse? The leading theory was that the atmosphere was cooling off, which would decrease the amount of light being emitted. But this didn't make sense either because as far as scientists could tell, nothing had changed. There were no large impacts that could have caused such an event, nor any nearby stars that could have cooled the planet by casting a shadow. So what happened? Well, in 2010, a group of scientists published a paper outlining a strange hypothesis, an idea so bizarre that it sounds straight out of science fiction. They claim that Saturn's atmosphere is actually raining down into its interior, causing the planet to shrink. And not only that, but that this process is speeding up, causing Saturn to cool faster than expected. Now, you might be wondering, how does a gas giant rain? And it's a great question. Before we can answer that, though, let's take a moment to talk about what makes Saturn unique. As I mentioned, Saturn is a gas giant. That means it doesn't have a solid surface like Earth, Mars, or Venus. Instead, it's mostly made up of hydrogen and helium, the two most abundant elements in our universe. These elements exist in such high concentrations that they form a colossal ocean that stretches over 6,000 kilometers deep. Beneath that is a layer of ice crystals mixed with rock and other materials. But it's not really a solid surface because anything deeper than 100 meters beneath this ice layer is still in a liquid state. So if you were to visit Saturn, you wouldn't be able to walk on it, but you could fall through its atmosphere and eventually come to rest in its gigantic metallic hydrogen ocean. Now that you understand how Saturn is structured, let's get back to that big question. How does a gas giant rain? Well, imagine you're standing on a beach on Earth and you feel the wind blowing across your body. You know that wind is simply the movement of air molecules colliding with each other. Some of these collisions are more forceful than others, and when they are, it'll send some air molecules flying upwards. As they rise, they lose energy and slow down until eventually they stop and fall back down again. It's a constant cycle of rising and falling air molecules that we experience every time we step outside. But on a planet like Saturn, things are a lot more extreme. Saturn's massive gravity compresses hydrogen molecules incredibly tightly together, which means they move very fast. Sometimes these collisions are strong enough to send whole groups of molecules flying up through the atmosphere. Because Saturn's atmosphere is mostly hydrogen, these groups of molecules are made almost entirely of helium. Think of it as a giant game of pool where the helium atoms are the white balls and the hydrogen atoms are everything else. When a collision happens and some white balls get knocked away from the pack, it's the same thing. On Saturn, some helium atoms get knocked up through its atmosphere. But unlike our game of pool, Saturn's helium doesn't just bounce off the top of the atmosphere and fall back down. No, instead, these lucky helium atoms reach the boundary between the atmosphere and the ice layer and begin to condense, turning from gas into liquid. As they descend further, they eventually become part of Saturn's infamous hydrocarbon lakes, but not all of them make it. Some run out of momentum before reaching the lakes and end up as part of Saturn's thick rings instead. This process of helium condensing in Saturn's atmosphere removes some of the helium that was once there, which is why scientists think that the upper atmosphere of Saturn is constantly raining down into the interior. But here's the kicker: scientists don't think that this process is new. They believe it's been happening for billions of years. In fact, they think that Saturn used to be a lot bigger than it is today and that most of its missing helium has been raining down for billions of years. But if that's true, why did it take so long for the atmosphere to thin? Well, here's where things get interesting. You see, this process of helium raining down is happening on other gas giants too. In fact, scientists think that the only reason helium is so abundant on Earth is because it rained down on our planet billions of years ago. But while helium is relatively light, it's still heavier than hydrogen, which is why it gathers at the bottom of Saturn. Over billions of years, the helium has built up until there is so much of it that it creates its own sort of atmosphere. Here, the helium atoms are under so much pressure that they're literally crushed together. And I mean literally, because if you squeezed hard enough, you could crush a helium balloon. And when the balloon pops, the helium escapes into the air. Well, something similar is happening on Saturn. Under such intense pressure, the helium atoms are fusing together to create heavier elements. Scientists have found that Saturn's core contains significantly higher levels of heavier elements like carbon, neon, and oxygen. They think that this is because the helium has been raining down and fusing for billions of years. But here's the big question: why does this happen on Saturn and not Jupiter? After all, both planets are made mostly of hydrogen and helium. And sure, Jupiter has a lot more mass, but that shouldn't make a huge difference, right? Well, not exactly. You see, Saturn and Jupiter are slightly different in composition. Jupiter has more hydrogen and less helium than Saturn. And that might seem like a small detail, but it's actually crucial to this story. You see, hydrogen has a special property that makes it perfect for nuclear fusion. When you squeeze hard enough, you can force the hydrogen atoms to combine and form helium. But to do this on Jupiter, you'd need pressures around 30 gigapascals. For comparison, the highest pressure ever recorded on Earth was 370 megapascals, meaning that the pressures on Jupiter are over 80 times greater than Earth's. But Saturn is a bit different, because Saturn has more helium than hydrogen. The pressure needed to fuse the atoms is much lower, just 7 gigapascals. This is possible deep within Saturn's atmosphere, but only in very small amounts. Jupiter's atmosphere, on the other hand, has pressures over 3 times higher, which is enough to fuse the hydrogen into helium at much greater depths. This is important because nuclear fusion creates a tremendous amount of heat, enough to prevent any helium from raining down. And that's why Jupiter is still so bright. It's radiating the heat from all the hydrogen being fused deep in its core. Meanwhile, on Saturn, the lack of fusion allows the helium to rain down into the interior, gradually shrinking the planet and cooling it off. Scientists have actually confirmed that Saturn is shrinking by just over 1 kilometer per year. That's around 6,000 times faster than Earth, and remember that this has been going on for billions of years. So it is no wonder that Saturn is now around 1,000 kilometers smaller than it was when it formed. But the question remains, why is Saturn shrinking so fast now? Scientists believe that it's due to a natural fluctuation in its atmosphere, kind of like the ups and downs we experience in our own lives. Every few years, Saturn's atmosphere goes through a period of intense storms and turbulence. And during these periods, even more helium rains down and the atmosphere cools off. Scientists predict that in another 1 billion years, Saturn will be completely dark, meaning that it'll no longer emit any light. That's how our optimistic science works. Thanks for watching. I hope you learned something new today. If you want to learn more about Saturn, check out this video.